Now, let's think about a slightly different problem. So let's do another problem. Let's try to find the equation of a plane through a point P0 with coordinates, say, 2, 1, minus 1, and with normal vector, again, the same guy, 1, 5, 10. Okay? So how do we find an equation of this thing? Well, we are going to use the same method. In fact, let's think first for a second. So I said we have our normal vector n, and it's going to be perpendicular to both planes at the same time. So in fact, our two planes will be parallel to each other. The difference is, well, before we had a plane that was perpendicular to n and passing through the origin. And now we have a new plane that's going to pass, well, not through the origin, but through maybe this point P0, and I don't really know where it is, but let's say, for example, that P0 is here. Then I will just have to shift my plane so that instead of passing through the origin, it passes through this new point. Okay? So how are we going to do that? Well, now, for a point P to be in our new plane, we need the vector no longer OP, but P0P to be perpendicular to n. Okay? So P is in this new plane if the vector P0P is perpendicular to n. And now let's think for a second, what's vector P0P? Well, we take the coordinates of P and we subtract those of P0. So that should be x minus 2, y minus 1, and z plus 1, dot product with 1, 5, 10 equals 0. Or let's expand this. Well, we get x minus 2 plus 5 times y minus 1 plus 10 times z plus 1 equals 0. Or let's put the constants on the other side. We get x plus 5y plus 10z equals, well, here we have minus 2 becomes 2, minus 5 becomes 5, 10 becomes minus 10. I think we end up with negative 3. So see, the only thing that changes between these two equations is the constant term on the right-hand side, the thing that I call d. And the other common feature is that the coefficients of x, y, and z, 1, 5, and 10, correspond exactly to the normal vector. Okay, so that's something you should remember about planes. These coefficients here correspond exactly to a normal vector. And, well, this constant term here roughly measures how far, when you move from, so if you have a plane through the origin, the right-hand side will be 0. And if you move to a parallel plane, then this number will become something else. So how actually could we have found that minus 3 more quickly? Well, we know that the first part of the equation is like this. Okay? And we know something else. We know that the point P0 is in the plane. So if we plug the coordinates of P0 into this, well, x is 2 plus 5 times 1 plus 10 times minus 1, we get minus 3. So in fact, the number we should have here should be minus 3 so that P0 is a solution. Okay, so let me point out. So maybe I'll put a 1 here again. So these three numbers, 1, 5, 10, are exactly the normal vector. Okay. And one way that we can get this number here is by computing the value of the left-hand side at the point P0. We plug in the point P0 into the left-hand side. Okay? Any questions about that?